The unit analysis helps us to make a conclusion on the possibility of specific physical equation. If we solve a problem, we use some math. And normally we use equations like something is equal to something. In mathematics, there are no units, only numbers. But in physics, there are numbers and those things we call units, those things we use to measure physical attributes of physical objects. And it's important that the unit of whatever expression you have on one side of the equation and the unit of whatever expression you have on another side of the equation be equal to each other. If those two sides have different units, that equation just cannot be correct. It's plain wrong. Well, again, we know that a unit is just, well, it works like algebraical variable. So eventually, we should be able to cancel all of them out. And that cannot happen if you have different units on different sides. So the unit analysis is the analysis of units. On one part, you can figure out the combination of fundamental units. On another part of the equation, you can figure out the combination of fundamental units, and you can compare if those two sides of the equation have equal units. That equation at least is possible. If units are different, that equation is just physically impossible. So this is my question again to everyone. What do you think about this particular equation? Well, I'm going to answer this question just for the sake of time. X represents some kind of a length. What unit can we use? Well, meters, for example. We don't have to use meters. We could use miles or centimeters as long as we use that unit consistently on both sides. So technically, it doesn't matter if it's a meter or a mile or a centimeter. It's some kind of a unit of length here and nothing else. On the right-hand side of this equation, we have a product of two variables. The first variable is speed. What do we use to measure speed? Miles per hour, meters per second. So some kind of a unit of length over some kind of a unit of time. And we're multiplying by time. To measure time, we're using seconds, hours, any unit of time will do. So if we look at the expression on the right and we compare with the expression on the left, do we have the same units? Yes, we do, because these two cancel out. They work as just regular algebraical variables. After getting them canceled out, we make a conclusion. Yes, this expression, well, at least possible, could work. What about this one? Well, yeah, we have it answered. Yes. What about this one? What do you think? If you think it is possible, please raise your right hand. That's a manual clicker. If you think it's not possible, please raise your left hand. Yes. If we check the units here, technically we can actually make one more step. We can cancel even the unit of length, which gives us expression which doesn't make any sense. Seconds equal 1. What does it mean? Nothing. So if you, by any reason, I don't know, arrived at the expression like that, if you check the units, you should make a conclusion. Something somewhere just went wrong. Any questions?